Hey everyone, we have a full crew on the couch today. So first of all, let's give some folks time to come in, and get situated, take a seat, relax. Um, so we're going to have a really cool demo today. Great conversation around a newly GA'd feature, which is HashiCorp Consul Service Mesh on Amazon ECS. So the crew here, we have folks from the HashiCorp team that we're going to introduce in just a moment, and then we also have a special guest that helped build some really cool stuff internally at AWS with the CDK. So I won't do any more spoilers. So let's start with just doing some introductions. So Luke, let's start with you. Say hello and all that good stuff.
Hey everyone, my name is Luke Kaiso. I'm a principal engineer at HashiCorp, and working on Consul for the last 3 years. And yeah, it's great to be here.
Awesome. Paul, you want to say hello?
Hey, I'm Paul. I'm a senior software engineer at HashiCorp. I joined this year working on Consul ECS.
Nice. And then I'm going to go down. We'll go to Eric.
Hey everyone, I'm Eric Haberkorn, and I work at HashiCorp as a senior software engineer. I've been at HashiCorp for just a couple of months working on Consul ECS integration.
Nice. All right, Parag, finish us. Take us home.
Hi everyone, I am Parag, a software development engineer at AWS. I work in ECS DevX team, and currently I'm working on Consul Mesh on ECS.
Fantastic. So, just to kind of start, let's talk a little bit about, two things. Let's first of all just talk about what was released, and maybe, Eric, maybe you can talk us through at a high level, just A, what is Consul, and B, let's maybe talk about what a service mesh is, and why is this such a big deal?
Yeah, that sounds good. All right, so let's start out by talking about what is a service mesh in general, since they can be a bit confusing. A service mesh is an infrastructure layer that provides a bunch of different things. It provides service discovery, meaning it keeps track of where service is running, how to access them, the health of the services, and things like that. It also provides observability into the network layer. I don't know about you, but in the past, I've spent countless hours trying to figure out if a problem is networking related or not. Service meshes do an awesome job of answering these types of questions. Service meshes also provide secure end-to-end communication between microservices using MTLS. And they also allow practitioners to specify whether or not services can interact with one another. And then the final thing that I'm going to talk about, but there's a bunch of other things too, is stability. Service meshes allow error handling, retry logic, circuit breakers, and things like that to be centralized into the mesh itself. So that means that changing this retry or error handling logic, it doesn't need to happen across hundreds of microservices in potentially different programming languages. It can happen in one single place within the service mesh. So once a service mesh is properly set up, sidecar proxies run next to every service, and all network requests go through these proxies. And then to go on to some cool things about Consul itself is that it isn't tied to one specific way of running things. It isn't tied to Kubernetes or ECS or VMs or any other different way of running things. So that's one really cool thing about Consul, along with tons of other things.
And I wanted to just quickly touch on, Eric. So, service mesh is really amazing. There's a lot of features packed into a service mesh, and I think sometimes as an operator, if you're advanced and you're already running a service mesh, we kind of take these things for granted. But if you were to go to a world where there is no service mesh, you as an operator, as a developer, when you think, if you're in a microservices environment where maybe you have, it's a polyglot application. I have one team writing in Go. I have another team writing in Python. Each team would have to think about, if we have mutual TLS as a requirement, service discovery, all of these things, each team has to think in their code, how do I solve these problems? And each team's going to do it a little differently. it's a lot of complexity. So the service mesh kind of just sits right next to your application, right? In the container, as you said, a sidecar, and it's handling, all these advanced functionality is built into the service mesh. So you as the developer, you're just focusing on your code, right? Getting your code out and doing what you need to do, and less about all the operational stuff.
Yep, exactly. Concentrating on providing business value as a service owner is awesome, and getting rid of a bunch of code that ends up being incidental complexity and can be pushed somewhere else. That's always a good thing.
Absolutely. So, and also, by the way, for folks in chat or for folks watching, if you have any questions, the chat's here. We're glad to talk through any questions you have. We'll answer them live. So please, or if you just want to say hello, I also like when people say hello in chat too. It feels a little lonely, here on the couch and without anyone talking to us. Okay, so was there anything else anyone wanted to add before we go right into the demo? Okay, all right. So Parag, why don't you so Parag's going to walk us through a demo, and we had mentioned the CDK. Parag, before you demo, why don't you tell us what did we release in the CDK? Let's walk through that, and then let's actually just go into the demo and show how it works.
Yeah, sounds good. So as you know that today we have these cool and talented people from HashiCorp who's talking about the Consul service mesh, and they'll be talking more about it in depth in a while. But I am here to talk about the service extension in CDK. So today we have a new service extension in CDK called as ECS Consul Mesh Extension, and so I'll mostly be talking about this extension. So before we get into the technicalities of what this extension is and how we want to implement that and everything, before that, I want to tell what we will be building alongside to understand the extension. So I can share my screen and you can see.
And Parag, really quick, I'm so sorry to interrupt. I just one thing I want to add is for folks who maybe are here that aren't familiar with the CDK, the CDK is the AWS Cloud Development Kit. It is essentially a way to define your infrastructure as code using a familiar programming language. So whether that's Python, TypeScript, Java, Go, .NET, I mean, the list goes on. But you can declare your infrastructure as code based on a familiar programming language. So and it also, so when you build on the back end, it's building CloudFormation as your cloud assembly and then deploying that for you. There's also CDKTF, which can output the Terraform and so on. So anyways, just wanted to set the stage here. Continue, Parag. Sorry, I talked too much.
So as an example, we will build a simple greeter application, which will generate random greeting messages with random names. For example, it will generate, hey Adam, hi Paul, and so on. And this is the architecture you can see here of the greeter application. So you can see the public application load balancer is going to route the traffic to the greeter application from the internet. And greeter application will use private application load balancer to route the traffic to the greeting and the name service. So this is the traditional implementation of the application. But if you go to the next architecture, so this is new cool architecture that we implemented using Consul service mesh, where the application load balancer will now route the traffic to the greeter service, but greeter service will internally use Envoy proxy to route that traffic to the required services, which is called as upstream services. So you can see here the Envoy is sitting next to the application container. There will be a couple of more containers who will be sitting right next to the application and Envoy container. That is Consul client and mesh in it. So Eric, Luke, and Paul will talk more about those containers in depth in a while. So we can dive straight into the service extension world now. So what is service extension in CDK? So for those who don't know that, the service construct in CDK can be extended with an optional service extension classes that add supplemental ECS features, including AWS FileLens, Amazon CloudWatch, then App Mesh, and now brand new ECS Consul Mesh extension will be a part of it. Though it will be living in a different module, which is called as AWS Quick Start. So let's discuss more about the extension while we implement it. So this is my code. So before we get into coding and implementing our application, I want to tell you that you need to complete few prerequisites. That is, for example, make sure that your console server is up and running, and if you want to add any security features to it, then make sure to enable that on your console server. Then make sure to store all the secrets and certificates on your AWS secret manager secrets. So once you do all these, you know, prerequisites, then you can come and do actual coding. So for your information, we can implement this, we can create this infrastructure for like environment and console server using multiple options. For example, you can use CDK, you can use CloudFormation, you can use Terraform module. So there is a link where you can go and see how you can implement these resources using CDK and CloudFormation. So personally, I use CDK because that's that's what I like. So you can see my environment.ts here. Uh,
Can
Basically,
you
I'm
zoom in
just
a little bit, Parag? Sorry to interrupt.
Yeah.
Just little zoomage, please.
Yeah, sure.
Thank you. Always throwing a wrench in things.
Is it better now?
Yeah, I think so. That looks good. And folks in the audience, if you need more zooms, just let me know.
Sure. So this is the environment.ts file where I'm basically creating my environment, creating my VPC, then security group for the console server and security group for the console client. And you can see I'm creating my cluster over here. So that's pretty much it in the environment. Then in the console server.ts file, you can see I am, let me just hide that. Yeah. So here you can see that I am getting the Amazon Linux AMI, adding some roles so that I can store my secrets to AWS Secret Manager secrets, and then some configuration related to the console server. And I'm instantiating my console server and tagging the name to it so that I can use that name. I can reference that name later while connecting my services to that server. So
could we just really quick take a pause there? So these are the prerequisites in order before we even deploy our containers and with with the sidecars, we need a console server running, right?
Correct.
And this is, if would you call it, this is like the control plane, right? We want to deploy the console control plane. Cool. And this is so when we launch our tasks, our containers, they're going to be able to register or be able to communicate with that console server to know about everything in the environment.
Yep.
Cool.
Exactly. And then we move to microservices.ts where all the magic happens. So look at this code. So this code is really small and does bunch of things. So I am just importing my security groups that I just created, and I am building basic properties that I want to send to my ECS console mesh extension, which will have retry join string, which will tell which server our services wants to connect to. Then these are two security groups. Why we are sending security groups to the extension? Because extension is going to take care of adding right ingress and egress rules so that your services can talk to the server and vice versa. And so that only in the mesh services can talk to each other and not any other service which is not allowed to talk to our services. So that's what our extension will take care of. Then these are two certificates and secrets that is enabling security features on my Consul server and services. So that's why I'm sending that also to my extension. And optionally, you can send Consul data center because it defaults to DC1. So if you want to keep it DC1, then you don't have to send that. And now here, this is the traditional way of, creating your name description. Just write new service description, and you can add your application container to your service description now. And it needs very basic parameters like image. Image will be the image of your application, and then CPU memory and the traffic port where your application will be serving traffic. So once you add these, basic parameters to your container, now you have your service description with the application container. Now just spice it up this, container with one line, which is here, which adds ECS console mesh extension on top of your service description with few basic properties and uh, service discovery name and port number, and boom, and then all the things will be taken care by extension. For example, extension will set rights, ingress and egress rules to your security groups. Then it will add environment variables to your application container. It will add three more sidecars to your service, which Eric mentioned, like mesh init, Consul client, and then Envoy proxy. All these containers will come and sit next to your application container. So bunch of things happen behind the scene, and you just have to add these couple of lines, and everything will be taken care by the extension. And then
So Parag, sorry to interrupt really quick, but this is where really the power of the CDK comes into play here.
yes,
Is the CDK, so Parag is the one who built all of the really cool stuff behind the scenes. And so you, as the user, when you're deploying with the CDK, you use this construct. So the idea of constructs is we build a lot of opinion into the constructs. The higher the level of a construct, the more opinion and the more automation that's built in, or abstraction that's built in. So you just define a couple of lines, and then we build all the rest. So the things that he was talking about, like adding sidecars, configuring egress, like these are things that ingress, egress, these are things that you would have to statically define if you were just doing this, on your own. So all that opinion's built in. You just, with the ECS service extensions, I'm just using the console mesh extension, passing in a couple familiar parameters, and that's it. The rest is all built and taken care of behind the scenes. So I just wanted to highlight that because I think that's one of the reasons why folks love CDK so much. Outside of that, you're using a programming language. It's the opinion that's built in.
yeah, and add to your point, Adam, how easy CDK is. Just with these three lines, I just want to show our customers that, viewers, that these all resources are getting created by just those three lines. And you can see how much effort you have to put in if you want to do it manually. Yeah, it just goes on and on and on. Yeah.
This is my favorite thing to do with the CDK is I'll synthesize the cloud assembly, which is CloudFormation, and then I'll pipe it to like a word count just to see it's like 1,500 lines, but I just defined it in 3 lines. So that's really cool.
Exactly. Yeah. So you add these 3 lines and create your service with the service description and environment details, and that's all. Your service is ready. It's up and running from here on, and then you can similarly create. You can do the same things that you did for the name service. You can do for your greeting service and greeter service. Just the copy paste of the code and changing few parameters like service discovery name and port, and that's all. So you just have to copy paste that small amount of code for all the services, and the extension will take care of everything. So now the interesting part is over here. Now your services are up and running in the console mesh, but they still don't know which other service they want to talk to. So if we go back here, we want our greeter service to talk to the greeting and name service, right? So we have to tell that to our code that do greeter.connect to name and greeter.connect to greeting with the local bind port. So then greeter service will talk to both name and greeting service on ports that are defined there, like 8080 for name and 3001 for the greeting. So what is local bind port is it specifies the port to bind a local listener to for the application to make outbound connection to these upstreams. So in this case, the upstream is name and greeting. I know Luke, Paul, and Eric will talk more about this local bind ports and all the other sidecar containers. But just for the reference, I'm giving the detail about what it is. So you just have to give two parameters, that your service name and where you wanna, connect to that upstream, and Gradle will start connecting to those services.
So do we have this deployed? Can we see this in action?
Yeah, yes, definitely. So we can come to, and you can do CDK synth. And okay, I have already done that, but just for you, I'm doing it again. And
when you run the CDK synth, that just gives you the what we call it the cloud assembly, which is the underlying cloud formation.
yes, so if you see here, so the retry join logic that we added, so you can see it has been added to the command. Then you can also see that environment variables have been added automatically. So just wanted to mention one thing over here: the service discovery name that you give, that name will be capitalized and underscore URL will be added in front of it. So you just have to know that you have to use your service discovery name in capital, add underscore URL to it, and then you can access your upstreams using those values. And behind the scene, we will use this value to connect to the upstream services. So that's one thing. And then you can also see here that upstreams got added when you do connect to. That's why this name upstream and greeting got added with the port that you mentioned in the connect to method. So yeah, that is it. And when you do CDK deploy, it will deploy the stack. It takes like 3-4 minutes right now, but I don't want to waste your time, so I just have already deployed my stack.
We already have a cake in the oven.
Yes, so you can see here, you can see greeter service. You can see that greeter service is connecting to the greeting and name. So if I go here, it can give the other way topology for only one service. And when you go to the instance, you'll get more details, which Paul will talk about. And yeah, and if you go, my session has been expired. I have to go in to show you how does it look in AWS.
With that code you just deployed. So we deployed this name service, which you go into this name service, you make an API call and it greets you, right? It returns a greeting. So with just the code you had there, it deployed the Consul service mesh. We deployed the Consul, the control plane. And then when you deployed your services with those helper methods, it plugged Consul in. It's built all the sidecars and all that logic for you, deployed it, and now your services are talking via service mesh with Consul.
Yeah, so I have the load balancer link over here, which will hit the greeter service, and then greeter service internally talk to other services using Envoy proxy. So if I do refresh, so you can see on every refresh, the greeting message and the name is changing. Yeah, so that's pretty much it. And I don't think, okay, I have logged out of AWS, but yeah, that's how it looks in even AWS. If we go to ECS.
And so for folks here that maybe aren't familiar with ECS, ECS is it's a container orchestration service, but there's just a ton of benefits to using ECS. My favorite kind of talking point when I talk about ECS is the control plane is fully managed. So the orchestrator from a control plane perspective is fully managed. You never have to think about upgrading, rolling out a new version of your control plane. It's just there, and you once you create your cluster, which is just a logical namespace and basically a way to organize all your containers, that's it. You're ready to go. So this integration is so nice, though. I just wanted to comment that I know we went kind of fast, and I pasted the code, the GitHub repo. Shoot, I lost it. Here it is. So if anyone wants to walk through this, we do have an example here. So you can walk through this on your own with the CDK. But was there anything else, Parag, you wanted to walk through before I hand it off to Luke to maybe talk more about?
No, just wanted to show you this cool thing that you just added your application container, and all the other sidecars got added just by those 3 lines, and giving some parameters which are required for extension to work. So just basic properties you have to provide to us, and behind the scene extension will do everything for you, and the services can talk to each other with the secure manner. And I guess that's it.
That's super cool. Question came in. I just want to touch on from Kevin. Hey, Kevin. So in this particular setup, which looks to use Fargate, what sort of cost should you expect? So from the AWS side, when we talk about costs, Fargate, you just pay for what you use. So when you run a Fargate task, you're just paying for the vCPU hour, or by the minute. So you pay for whatever you use. And then any other costs, I guess, Consul, in this case, we're using open source, right? But Luke, maybe you want to talk about what else am I considering from the Consul side here?
Yeah, so I think the additional cost would be around the additional CPU that's used to run the proxy that's in your task now, and also some of the other containers that run in the task there. And we're actually in the middle right now of kind of like quantifying exactly how much that uses. But in general, it'll just scale with your application. So if your application is making more requests, then the proxy needs to spend more time. But if you remember back to Parag's like the old way architecture, where you basically have like an ALB in front of everything, ALBs are expensive. So I'm pretty sure that you're going to have a reduction in cost there. We're actually going to quantify this over the coming weeks, but I think that's kind of like the cost that you might think about adding, but also the cost you might think about subtracting, where you don't have these load balancers everywhere now.
It's a great point. Yeah, that's a great point. And again, Fargate is pay for what you use. Fargate, you don't, you're not managing the underlying EC2 instances. So you don't have to, patch secure hosts in that way. You just focus on your application. You're sidecarring the proxy, the service mesh. So it's all just defined in one place. So yeah, Luke, why don't you, kind of jump in and let's talk about all the good stuff that we just saw.
Yeah, for sure. So I think at this point, a lot of folks are thinking, well, previously you had these ALBs and my app looked the same. Now you've added all this complexity and my app still looks the same. So kind of what am I getting out of this other than maybe a reduced cost in ALBs? So I think the key part of the service mesh that enables all this is now all of your traffic is running through these proxies. And so now you can do pretty much whatever you want to this network traffic. You don't have to make any changes to your code. You don't have to redeploy your app. And there's a centralized control plane where you can make all of these changes. So from one point of like the UI or through like a configuration entries that we're going to show later, you can basically do whatever you want to all the traffic across all of your services. And not only that, but maybe this is a really old service running on like Java 4 or like PHP 6 or like something really old where you never really wanted to touch that code, but you wanted to maybe make some changes to the network traffic. Well, you just put this proxy in front of it. Even if it's on old Java, old PHP, it's still probably talking TCP, it's still talking HTTP, probably not talking gRPC. But it doesn't matter because you just throw that proxy in front of there and now you have all this control. And so that's what we're going to show over the coming demos with Paul and Eric. It's kind of like, okay, now you have this proxy. I've taken on this complexity. What are you going to give me back for it? And I think that's kind of where it's really cool with all the things you can get out of a service mesh. And a couple other points I want to touch on. So Parag showed the CDK integration. But if you're using Terraform, we also have Terraform modules that kind of work in the same way, the same UX, where you don't really have to worry about what's going on behind the scenes. You kind of just use your original ECS task, and you kind of just plug it into our module, and we add all those sidecars in for you. So yeah, you can check that out. I can send you that link, Adam, to post on the screen about where the module can be found. And another thing I want to touch on was the Consul server, so the control plane. So Parag deployed that using CDK, and he deployed it to an EC2 instance. But you can also deploy the Consul servers to a managed version of Consul called HashiCorp Cloud Platform, where it'll manage all those servers for you, and you don't have to worry about like the state behind it. And you can kind of, if you're a Fargate person, you're kind of like, I don't want to manage servers. I thought the whole point, we don't have to manage servers. So this is an option for those people that don't want to manage those servers. And I'll send you the links, and you can put them on the screen. But yeah, so that's what we're going to talk about next. Is kind of like, what features are we getting out of this? So I'll hand it over to Paul for that.
And before Paul jumps in, I just want to say, first of all, I used Consul, previously in a previous life prior to coming to AWS and working here, and I just use it as a key value store. But I got to tell you, it's so powerful, and the Consul has grown so much into such a powerful service for a service mesh key value store. There's so much you can do with Consul now, and I love the direction that y'all have gone with it, and you're just continuing to improve it, make it nice. That UX, like in the in the UI there, is so nice, easy to use, easy to read. So I just wanted to say I really dig it.
Yeah, it was really just a natural evolution. About 3 years ago, when we first released the Consul Connect, which is we call the service mesh feature, it was like, even at my old company, before I even joined HashiCorp, we were already doing our own homegrown service mesh on top of Consul, because Consul had all that data about where your services were running. And so we wanted to just throw an Nginx proxy in front of there and kind of like route out to the different services, right? And so it was just natural to use Consul for this. So it was kind of a natural extension where all of our customers were kind of running these things themselves. And they were like, why don't you integrate the service mesh functionality into Consul? And that was kind of how it all happened.
Super cool. And I just posted the links in chat. So if anyone wants to just read up more on the cloud platform or the Terraform module. And by the way, we have a ton ECS customers love Terraform. So I know a lot of them use Terraform. So definitely check out the registry there. So I forgot who was up. Was it Paul? Sorry, I interrupted.
Yep. Yeah.
Cool.
No worries.
With the cool radio voice.
Yep. All right. So yeah. Hi, I'm Paul. I'm engineer at HashiCorp. And yeah, so I'm going to share my screen real quick. Basically, what I've got here is kind of that same greeter application that Parag deployed. The only difference is I use the Terraform modules to deploy it. I won't get into the Terraform modules here. I'll just kind of give you a tour of the Consul UI and kind of maybe familiarize some people that haven't seen it before. So what you're looking at here is the Consul service catalog. So this shows like what services have been registered. So I actually have here like my containers that have started, kind of join the mesh, and when those tasks start up, they register themselves with the Consul cluster kind of automatically. And so we've got kind of a greeter service with an instance, one task in ECS, a name service, and greeting service. And you can kind of jump in here. Parag showed this a little bit. You can see like this greeter application accesses, these two other services. So you can see your topology and which upstreams your service accesses. You can see your instances. You can jump in and see health checks, which Eric will talk about. There's some routing configuration and like some tags and things. But basically, like this is kind of your control plane where you can see everything kind of in your mesh for your service, and you can kind of make changes and things. I guess the first kind of demo we can give Consul is some Consul intentions. So I just want to prove I have this greeter application running. Kind of I refresh and it kind of works. What I want to do is add an intention that's basically going to deny all traffic. But first, maybe I'll explain what an intention is. So I think an intention is basically in Consul is a kind of an authorization mechanism you can use to allow or deny traffic to other services. And if I jump into the intentions view, so here this is kind of what it looks like. So what I can do is I can create, a deny all rule. So no traffic is allowed from any service to any other service. And if I refresh, this might take a couple. Yeah, we get a 403 error. So what basically happened there is I added the intention that went into the control plane, and Consul updated basically all the proxies in the mesh to just deny traffic from each other. And so what I can also do is kind of create these identity-based rules to say like this particular service can or cannot kind of communicate with some other service. And so in order to kind of allow my greeter service to work, I'm going to create a couple of intentions here.
And you didn't have to deploy anything, by the way. There was no service deployment for this to happen.
Exactly. Sorry, I have to fix this one. Yeah, this is the whole point is there's kind of this all happens in the proxies. There's no application changes needed. You can kind of do this all from Consul. Sorry, I'm having a little demo fun. All right. So yeah, if we refresh, it takes a couple, but there you go. Yeah. So yeah, those are Consul intentions. I think you might be wondering like, well, why would I use these? What good are they? I think if you think about like more traditional sort of access control or authorization rules, you might have they're typically like IP based. Like you have firewall rules with IPs and ports, or you have security group rules as well. And you've got to kind of know like all the IP addresses or the ports that are involved. With kind of Consul, you actually have identity-based rules. So Consul has this internal CA, and it distributes certificates to all the proxies. And so proxies communicate with mutual TLS. They encrypt traffic between each other, and they know the identity of every service they're talking to. And so it's just intentions are just a layer on top of that to say, when you talk to this service, allow or deny traffic from it. And yeah, so yep.
Yeah, and I think one thing I'd add is, so the way it works under the hood, like Paul said, is it's using SSL certificates, which means that, say you're going through a proxy to get to an on-prem data center, for example. Well, a security group won't necessarily span beyond the proxy, because when the on-prem data center gets the traffic, it's just coming from the proxy. So it doesn't know which was the source service, right? If you're doing it IP-based. But with these TLS certificates, with this identity-based security, it's encoded in that certificate when it receives the request on the other side, which service sent that request. And so we can continue those authorization rules. So these span multi-data center, wherever you're running Consul, it can understand these authorization rules. And the other cool thing that we didn't show is that you can actually specify like specific HTTP routes that aren't allowed. So say you had like a /admin section of your website you didn't want traffic to. Well, a security group rule isn't going to help you with that. It's just, it's IP to IP, you're good to go. Here, you can actually specify specific routes that aren't allowed to be accessed, specific headers that can be sent. So you have a lot more power in terms of those authorization rules.
You brought something up that I was thinking about and I forgot about it, and you just reminded me. So this is there are some complex use cases where folks may have, some workloads. Hybrid is very common, right? Folks have a data center and they're running in AWS. So theoretically, I could have a mesh that spans across, right, data center and AWS. Is that fair to say?
Mm-hmm.
So, we have ECS anywhere. There's times where folks need to, let's say that you have the legacy, term. We have a database that's sitting in the data center. We can't move it right now. With ECS anywhere, I can run my task, my containers in the data center. The control plane is the orchestrator's managing the tasks, right? Making sure they're up, but they're running in my data center. Now, if I'm using the Consul mesh, I'm able to communicate with the service mesh, and that's all managed. So that's a really cool use case that a lot of folks could benefit from.
Yeah, absolutely.
Super cool. So Paul, thank you for that. And Thomas, thank you for the kind words. We appreciate that. Thomas is having a good time. Glad you're having fun, Thomas. So Eric, are you going to jump in now and do some more cool stuff?
Yeah, yep. Let's
All
do
right.
that. Could you share my screen? Awesome. All right, so I'm going to start by talking about how this kind of works under the hood. Like Parag showed how simple it can be to use Terraform or CDK in order to configure all of this, but there's actually a lot going on. So I'm going to start out by talking about what containers are running. So I pulled up one of the tasks that's running on ECS, and here's the containers that are running. So there's a Consul client, and this Consul client communicates with the rest of the Consul cluster, which is the Consul servers and other Consul clients, to ensure that the services that it knows about are up to date and just that everything in general is up to date. The next container is Meshinit, and Meshinit is responsible for registering services with Consul, registering the sidecar proxies, ensuring that health checks are properly set up, and generating the initial config, the Envoy config for the sidecar proxy. The next container is the health sync container, and I'm going to talk about that a little bit more next, but that syncs statuses from ECS health checks into Consul itself. The next container is the greeter container, and this is the application code itself. And the final one that we've been talking about so many times, it's the data plane itself, and that's Envoy, the sidecar proxy. All right, so while working on Consul ECS integration, we put a lot of effort into ensuring that the user experience is as seamless as possible. And there's a bunch of different areas that we did it, but one area that I'm going to dig into is health syncing. So let's walk through the exact way that health syncing is used and works in general. So health syncing refers to Consul ECS's ability to automatically sync ECS health checks into Consul. To make this happen, a couple of different containers are used. The Meshinit container registers a special health check that will contain the ECS health statuses. And then after everything is running, the health sync container will continuously pull data from the ECS task metadata API. And whenever that status changes, it's pushed into that health check. So if we go here in the UI, you can see that there is a Consul ECS synced health check, and now it shows up as healthy. After Meshinit runs, it will show up as unhealthy because the container hasn't started, so health checks aren't passing. And then after a while, when the container starts up and ECS registers that service is healthy, the health sync container will see that that changed from the ECS task metadata API and then update that status within Consul. So yeah, that's the gist of how health syncing works and an overview of how containers work.
And Eric,
So
did I understand
Yep.
correctly? So I set my health check in, like, with ECS, you can set your health check in the task definition, like a container health check, and Consul's actually going to recognize that that's my health check, and it's going to use that to determine health.
Yep, exactly. There's a number of different factors that we use to determine, and it's probably going to change over time. But yeah, the gist is if you define an ECS health check, we push it into Consul, so you don't have to configure Consul native health checks, which are health checks that Consul actually runs itself, rather than coming from ECS or somewhere else. And so you don't have to configure that. You just have to configure health checks in one place, and Consul ECS just makes it work.
Nice. Love that.
Yep, awesome. So the next thing that I'm going to talk about is metrics. And Consul ECS, or not Consul ECS, Consul in general provides tons and tons of metrics that you get for free just by using it. And these metrics can be sent to Datadog, StatsD, Prometheus. In the case of this demo, we're using Prometheus. So just glancing at the UI, this is the same page that I believe Paul showed earlier. And this page shows things like requests per second, error rates over time, latencies, all sorts of awesome things that are really, really helpful when things aren't working. So let's just go to the app, refresh it a bunch of times, and then let's see if we can get the graph to actually go up. All right.
And just another one of those things, just, out of the box with service mesh, these capabilities, like this insight is so powerful and so helpful to operators. And it's just there. Like that's amazing.
Yep, definitely. So if you look here, the graph went up and
Nice.
It's showing that it's getting a bunch of requests. So that during an incident or just when doing normal debugging, this could be super helpful for figuring out what's going on with a real production issue. So the last thing that I wanted to talk about was that this is the code. This is the code that's actually running, that's showing up over here with getting tons of requests. There isn't any, it's not instrumented with any metrics. That's coming from Consul itself. And not that they're set up for this particular example, but if there were circuit breakers and retry logic configured in Consul, you also wouldn't have to have that set up there. So going back to a point that we've talked about a couple of different times is service owners can concentrate on delivering actual business value rather than things that they just don't have to think about when they're using Consul.
Yeah, that's huge. That's huge. I mean, it's again, like I think regardless if you're writing an application in production, at some point you're going to want to add some instrumentation, to get your own metrics. But out of the box, just having this, getting kind of this default set of data is just super helpful for those that are getting started. So, and it's so nice. That UI is so pretty. I love it.
And it's not just, so those are the top line metrics we show there, but there are there's metrics I didn't even know you could metricize coming out of Envoy. Like we're only showing 4 of them, but there's TCP connect times. There's specific TCP packet delays. You have histograms for everything. There's thousands of metrics that come out of your Envoy proxy that you're just getting for free. And those get pushed to, you can view them in Grafana or wherever you want to view them, right? We're just pulling these kind of top line red metrics out here. But there's so many that come out of it. And even when you're doing your own metrics libraries, right? If you put it in code, oh, I'll just use my metrics library and it records those metrics for me. Well, it's probably missing some. You're probably using different keys. So you can't build unified dashboards between different services because someone prefixed their keys with Luke, someone prefixed them with Adam, right? You get this across every single service in your stack, even the really old ones. You get these super detailed metrics out of it.
Great point. And great point with the old services, right? You don't have to retrofit something into the code base. It's just there.
Yeah. I mean, they're probably using statsd and they're using libraries that you can't even if you try to build the thing on your own laptop, it would be oh, those don't exist anymore. Do you know what I mean?
Yep. Yeah. Great point. So Eric, was that, I don't want to stop you short if you're still going, but I know Paul is going to demo some blue-green stuff, right?
Yep. That's it for me.
Cool. Awesome stuff. All right, Paul. You're on the clock.
Cool. Yeah. So, let's see. So yeah, I wanted to talk a little bit about Consul's kind of traffic management features. So yeah, I think the common theme has been you don't need to make any changes to your application. You've got these proxies, and you've got this control plane with Consul that allows you to configure traffic kind of in any way you want. And so let me jump in initially just to show we need some tags for this. Basically what I want to do is with this greeting service, you see sometimes it responds in German. That's actually a separate instance that we've deployed. So sometimes it responds English. And so what I'm going to do is I want to kind of set up some routing rules. I've got one task that I've got one instance of this task, that is tagged as blue. So this is the non-German responses, and I've got another instance that is tagged as green. And so this little demo is just going to show, that we can set up some kind of traffic management rules in Consul and direct all the traffic to either the green or the blue. In this case, I'll do the blue, and we should see hopefully only German responses coming back. Yeah, so I guess I'll just take a peek at the kind of routing dashboard. This is what you have with kind of no rules is the default. So there's a router that can match on different paths. In this case, the default is match all the paths, and it just sends them straight to the greeting service. So this resolver will send, the request will make it to some instance of the greeting service. I'm going to jump in a terminal real quick to apply some Consul config. And sorry, I've got some commands. So these are Consul config files. So the way you can control this is kind of with centralized configuration in Consul. And this is kind of two sort of config entries that I'm going to add. One is for the kind of splitter, is what Consul calls it, and the other is for the resolver. And these are both for the greeting service that we were looking at. So on the left, I've got, I forget if I did this backwards, but we'll find out. So I've got a couple splits, and I'm going to send 100% of the traffic to the blue instance. I actually do think this backwards. Give me
Green was German.
Yeah, I think you're right. I was testing before the demo. Okay, there we go.
You missed the wait.
Yeah. There we go. Okay. So we're going to send 0% of the traffic to the blue service, or the blue group, the service subset, and I'm going to send 100% of traffic to the green subset. And on the right is the resolver that just kind of defines what those subsets are. So I think I showed the kind of group tag or the metadata field. So the blue subset obviously just matches group on blue, and green matches the group on green. And sorry, I've got some Vim.
Oh, you got into weird Vim mode.
Sorry about that. All right, so I'm going to apply this Consul config, and it's super simple. There's this Consul config write, and I give it the file. So if I run that, that applies, and I've also got the same command for the splitter. And so this has written these config entries into Consul's centralized config. And if we jump back to the UI, now we'll kind of see, we have this view of what those kind of traffic management rules are. So it's matching all the requests, it's using the splitter, and the splitter's sending no traffic to the blue group, 100% traffic to the green group. And I guess now the moment of truth is, are we seeing only German? And it looks like yes, if I refresh a whole bunch of times. So yeah, and you can just as easily assign redirect the traffic, all the traffic to the blue group, reapply the config, and kind of do your blue-green deploys that way, or really other kind of deployment processes.
Right, like you could canary it, right? You could get all fancy.
Yeah. Mm-hmm. Yeah, so super cool, and again, no changes to your application. You can do this for any of the services in your mesh, old or new, whether they're in ECS or not. It's just super cool, centralized place to control, your traffic management.
So that's super dope. I mean, if I could just recap, I think time is probably not on our side right now, so we probably have to wrap up. I just wanted to say, though, when you think about this, we have observability that's built in to our mesh, traffic shaping, right? Advanced deployment functionality, canary, blue, green, the ability to import and to work with, legacy code bases that you may not have the expertise or just frankly, you don't want to touch it because it's so sensitive, right? You don't have to. You have the proxy there. What else? Oh, service discovery, right? All of this is built into the mesh. So there's a ton of value here. And now with this integration that's been GA'd with Consul and Amazon ECS, like it's just like, it's like peanut butter and jelly. It just goes together so well, you know? So at this point, you know, we probably should wrap up. Is there anything, Luke, Paul, Eric, anything y'all want to wrap up with? Any parting words of wisdom?
I think another one thing we didn't touch on because, you know, of time, but we did talk about it a tiny bit, was the ability to run Consul across multiple different platforms and multiple different regions. So like Amazon regions or your on-prem data center. So not only do you have these capabilities like within one ECS cluster, but you actually have them potentially across like all of your services across your entire stack, even for, you know, massive companies. And we have Consul running at massive scales, like 10,000 nodes kind of running Consul. So I think that's one thing we didn't touch on, was kind of like the multi-data center or multi-region capabilities here and multi-platform capabilities. So you could have these routing rules going from like a kube cluster to ECS or to your ECS. Well, we don't support ECS anywhere just yet, but like you could imagine that later too, right?
Super cool. Yeah, great points. Like this is not just limited to a POC. This is not limited to just one cluster. Like you can grow, and Consul will grow with you. So, guys, thank you so much for being here, like, and taking the time. Again, HashiCorp, always amazing products, amazing services, and honestly, the engineering folks are amazing too. Like that was really cool. And Parag, thanks for demoing the CDK integration. I know you worked really hard on that. And if y'all have any questions, this is my Twitter handle. You see, we got Parag's. Feel free to reach out to us on Twitter. Say hello. And in the meantime, have a great day. And yeah, we'll see you next time.
Thanks so much, Adam.
Thanks, everyone.
Thank
you.
Thank you.
Thanks, everyone.